Hello students, welcome to AriserTalent. I am your math teacher Arpita Sharma. Okay, so we were discussing triangles, and in triangles we have talked about some basic theorems and we have done some exercise on some questions. Now I left this question for you, that was in figure angle A equals to angle B and D is parallel to, this was not D, okay, this was prove that AD equals to B. Now draw the figure, that was A, B and C. Here we'll have this A and B to the base because these angles are equal, okay, and D parallel to. Now students, correct this is AB, okay. So DE is parallel to AB, prove that AD this is equals to BE, this, okay. Now student, what will we do? We have given angle A equals to angle B, which means we are having AC equals to BC, this is one. Then we have to prove that AD equals to BE. So now students, what we will do, will apply our Thales theorem, that is basic proportionality theorem. By Thales theorem, what will be having, CD divided by DA will be equals to C divided by EB. Now what we will do, we will just add 1 to both sides, adding 1 both sides in equation second. What will we get by adding 1? That will be CD DA plus 1. Here it will be CE EB plus 1. That will give you CD plus DA, and here it will be EB, and here CE plus EB. Right students? Now looking at the figure, we can find out that CD plus DA is equals to what? AC. So we can just write AC here divided by DA, and CE plus EB, that is CE plus EB will be equals to what? CB. So we will write CB in place of this divided by EB. That's equation third. Now in equation third, we have got AC by DA and we can replace AC by BC because these both sides are equal, okay. So can we replace AC by BC? Then it will become BC by DA. Now find if you are having something like AC, no, BC by DA here, BC by DA, no, BC by DA, no, okay. Now you can replace this BC to AC, okay. So if you replace it here, you will it will become AC by EB. Okay students, so now we can here we are having here AC equals to BC. So can we put BC in the place of AC or AC in the place of BC? Okay. So, in equation this we can write it like AC by AD will be equals to AC by EB. Okay. So, replacing the value of AC to BC, we will be finding this equation. Now, it will give you what? 1 by AD equals to 1 by EB. Okay. And we have to prove AD equals to B. So, we can just, by this we can just conclude that AD equals to EB. Okay, by reciprocal theorem. So, hence proved. So, what we did? We just applied Thales theorem here and added 1, and after adding 1, what we get, we will replace AC by BC or BC by AC from here and will conclude the result. Okay, students? Note it, I am going to rub this. Okay, so we have done so much of triangles thing here. May we have one more thing, that is, look here. This is a what? Trapezoidal. So, we will apply, we will have some questions on this. Okay, students. So, in this question we are having ABCD, a trapezium which with AB parallel to CD, sorry, DC, whatever it is same, and E and F are points on non-parallel sides. These are the non-parallel sides AD and BC respectively, such that EF, this is parallel to AB, this is given. Now, we have to show that AE by ED is equals to BF by FC. We have to show that these proportions are same, right? So, again with the process, we will start. We have given AB parallel to DC, okay, and we have given EF parallel to AB. Now, what I have done, we have construct this line. This is a construction, right, students? You are seeing this line, this is our construction. This is not given in the question, but we have constructed it and assumed that at a particular point G, it cuts the parallel line EF, okay. So, what we get from this, we have got two triangles. One triangle is ACB and the second triangle is ADC. Now, what we can do? We can apply Thales theorem to this triangle and we can apply Thales theorem to this triangle and can conclude something. Okay, students? So, to prove AE divided by ED equals to BF divided by FC. Okay. So, proof by applying Thales theorem, what will get? By applying Thales theorem, in triangle DCA, what we will get? This by this will be this by this, because what we have given, that EF, okay, EF is parallel to AB. Now AB is parallel to EF, parallel to DC. Okay. As AB is parallel to DC and EF parallel to AB, implies that AB is parallel to DC is parallel to AB. Now DC and AB are parallel, AB and EF, these are parallel. Okay. I have not written EF here, okay. So, parallel to EF. Now, EF is parallel to DC, that will be what? EG is also parallel to DC. Now, if EG is parallel to DC, you can apply Thales theorem here. So, what will it become? AE divided by ED will be equals to AG divided by GC. So, AE divided by ED equals to AG divided by GC. Okay, this is one. Okay, now we are having this here, right? We are having this portion here, but this is the different portion. Now, by applying Thales theorem again to what? To triangle, this particular triangle CAB, what we will get is CG by GA will be equals to CF by FB. Okay, this is equation second. Now students, you can see here CF by FB, CF by FB, but in inverse. So just not name it here, but just do what? Apply reciprocal here by applying reciprocal theorem. What we will get is, okay, we'll use this part. Okay, what we'll get? We'll get GA by CG will be equals to FB by CF. Now name it equation second. Now look at equation second and look at equation 1. This is CG and GA. Okay, you're having what? FB and CF. Now you're having this part here and which is here also, and this part here. Okay, now note this. Okay students, so comparing equation one and 2, we can have this. Okay, FB and CF, AG and GC. So this term AG and GC is common here. So this will be equals to this and this will be equals to this. Okay, so we can conclude that FB by CF will be equals to what? AE by ED. Okay, so we have to prove this only. AE by ED will be equals to FB or BF. You can write here. You can just write it BF, and FC. You can write CF as FC also. So, here it is proved. Note student. Okay, I am going to rub this. Okay, moving forward. Before proving this theorem, let's do one more question. So, you have given a triangle ABC, okay, where D is parallel to BC. So, question is, this triangle in this triangle you are having this as D parallel to BC, and you are given AD by DB equals to 3/4. Okay, students, and you have given that AC equals to 14 centimeter. This AC equals to 14 centimeter, and now you have to find out the value of AE. Okay, so you have given a question in which you have given a triangle ABC where BC is parallel to DE. Now you have given AD by DE, that is AD by DB equals to 3/4, and AC, this length is given 14 centimeter. Okay, this is your question. Okay. Now, how will you solve this? Simply, you will apply the Thales theorem. So, solution by applying Thales theorem, what will you get? You will get AD by DB equals to AE by EC. Now the given values are, you have to find the value of AE. Now you can write AE as AC minus EC, or you can write EC as AC minus AE. In this particular first method, we will be having what? AE in terms of EC, and in this particular term we will be having EC in the term of AE. Now what is our motive? Our motive is to find AE. So we have to write this equation in terms of AE only. So there will be only one variable or one unknown, I can say more precisely that one unknown. So it will be very easy for us. Now AD by DB is given easily 3/4. So we can easily write it as 3/4. Now value of AE we have to find, so we will write AE as it is. Now from this triangle, value of EC is equals to what? In terms of AE, that is AC minus AE, okay. This minus this will give you this. Now write it here, AC minus AE. Okay students, now you have given the value of AC equals to 14 centimeters. So just write it here, 3/4 equals to AE is what? No, AC is 14. So you have to write AE as it is, 14 minus AE. Okay. Now what will it give you? It will give you 14 minus AE multiply by 4, okay, multiply by 3. That will be equals to 4 multiplied by AE. Just sort it out. Okay. Then it will become what? You can send this here. So that will become 4AE plus 3AE. That will give you 7AE is equals to 42. That will give you AE equals to 6 centimeter. Right, students? So AE is equals to 6 centimeter is your answer. Now copy this question. Okay, students, you have copied it. Now I am going to rub this. Okay, so in last we are going to have one proof here. We have to prove something. So in this particular part we are having a triangle ABC. So if in triangle ABC, you can have it here also. Okay, A, B and C. You will be having here C, D, no, that's D and E. Okay, D and E. So D is parallel to BC and angle B is equals to angle C. So prove that this triangle ABC is isosceles angle triangle, right? So to prove this, you have to prove that this particular line is equals to this line. Okay, note the question. So this something, okay, you haven't given angle B equals to angle C, you have just given that angle D, this angle is equals to this angle. Okay, angle ADE is equals to angle ACB. So this angle is equals to this angle. Now you have to prove that triangle ABC is isosceles angle Okay, so look, D is parallel to BC. Okay, now if you are talking about this triangle, start proof by here. So how will you prove that this is an isosceles triangle? You have to prove that either this angle is equal to this angle or this line is equals to this line. If this line becomes this line, this and this line becomes equal, then you have proved that angle B is equals to angle C, right, students? So moving forwards, we have given that angle AGE is what? Equals to angle ACB. Now we have given this angle is equals to this angle. Now if this line is parallel to this line and a line is cutting both the parallel lines, then we know that this angle and this angle are equal. So, as DE parallel to BC, angle ADE is equals to what? Angle A, B and C. Right, this angle is equals to this angle. Second, now find out the common one. This is the common. So, by comparing equation 1 and 2, by comparing this equation to this equation, what we can say that angle ACB is equals to angle ABC. Now look at angle ACB, this is ACB and this is ABC. So, we have to prove this. If this angle, if the two angles in a triangle, if two angles are equal, then this is a isosceles triangle. So, triangle ABC is an isosceles triangle. So, it is proved now. Okay students, I am rubbing this, note this. Okay. Okay students, and we are having this question also, this theorem also. The internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. So, it is saying that if you draw an internal bisector of an angle, we are having a triangle, and if we draw internal bisector of any particular angle, then it divides the opposite side, it divides this side in the ratio of sides containing the angle, in the ratio this to this. Now, if I am going to tell you this is A, B and C, now if I am bisecting it at D, I am bisecting this angle and it is meeting at the particular D point, then the ratio of this to this, that will be AC by AB. This is the ratio of the sides containing the angle. Okay. So, this ratio will be equals to what? This ratio, CD by DB. So, we have to prove this in this condition where this and this are equal. So, we will be discussing this theorem in our next lecture, right? Okay students. So, just practice more and more questions, because when you talk about triangles, specifically triangles, okay, so in this particular chapter we are having number of questions. Okay, you can have theorems to prove, you can have to prove some angle, some triangle as isosceles triangle or equilateral triangle based on some given information, or you can have an particular kind of triangle where you have to you have given some specific properties or specific lengths have given to you, and what you have to do, you have to find something and how will you do that? You will just put the values as per Thales theorem, or the reverse of it, or whatever we have studied. Like this theorem we are going to study now. Now after studying this, there may be some questions in your exam. So in triangle, what you do is you will combine, that's combining, because in last question this concept was applied, okay. And you know this, that in this particular when you are having two parallel lines intersecting two parallel lines, in this case what happens, that you are having this angle equals to this angle, this angle equals to this angle. Now this angle is also equals to this angle, and this angle is also equals to this angle, and these angles are also equal. So these 1, 2, 3, 4, 5, 6, 7, 8 are somehow equal, and other these angles, these are also equal. So there are two sets of angles which are equal to each other. There are many more. So you have to combine all these things in this chapter triangle. You will study some new theorems also, and then we will have some fun with that. Okay, till then keep watching. Thank you.